Okay, so my name is Marcel Suter. I'm partner and director of libC Technologies. Our business is down to earth, okay, before lunch. We are basically building PKI for private trust or public trusts. It's also used within the world of qualified signatures and IoT, manufacturer, insurances, banks, and the case of the SSFN, which is the Secure Swiss Finance Network, which was built by SIX, and where actually we already had provided our PKI. The PKI is basically used within the context of the enterprise, and basically we started discussing about, what it means to have a SCION CA as a PKI for this project, and we started to look into the technology. I would say CAs are in the market for a very long time. It's on the market for over 20 years. It's not a super sexy technology, but actually it's still around. So, just have a good look at the dinosaur of the PKI because I've been in the business for many years. So basically, what did we need to provide the PKI for the SSFN? So first, we have something which is in common, which is basically the X509 specification. It's an RFC. It's all the definition of a certificate structure, and this is something basically which the PKI does. Then one particularity is basically that only elliptic curves are used within the PKI for different reasons. It's smaller, it's faster. I don't know if it's really safer when you deal with elliptic curve. You always have to be very careful when you generate your key pairs that you have good random generator. Also, when you sign, you use random values, so you also have to watch out that you get good values out of there. What's also different is you don't use CRLs or OCSP, okay, because it has to be really fast when you do the validation at the different points, and basically doing CRL lookups or CSP are pretty slow. So therefore, we also have very short lifetimes in the certificates, in the leaf certificates, and also the signing CAs. An additional structure which you wouldn't find is basically the TRC, which is signed, where you basically have the root of trust, which is included. So those are basically functionalities we don't really have in a standard PKI, and which we actually then built in to support the SCION CA. So SSFN, when they started, basically one of the questions was to, from the steering committee, or basically for all the governments, was to say, okay, we just want to have this thing to be secure. So actually, before doing anything with the PKI itself, or technically, or starting to generate keys and CAs and roots, you basically need to have your processes in check. You really need to work on your processes. And one of the points is, how are you going to onboard a new organization who wants to join basically a closed user group, okay? So you have to have a process where you can identify, qualify this information, okay? And for this, you have an organization which is the service management. The service management has one of the tasks is basically getting this data and validating this organizational data with real-life information into what we call an identity repository. Okay, and this identity repository is basically accessed using a 4IS principle with updates, modifications, so that we have the traceability to make sure that whatever information gets put into that system, which is going to get used for real-time validation, that we don't have rogue organizations. Now, once that you have prepared this information, this would be in one, and you onboard the new organization to join the network, so somehow you need to get it a certificate. Okay? So because in the standard you have very short-lived certificates, we decided basically for the first one, for the onboarding end user certificate or an organization certificate, to have a longer lifespan. So basically, we use the standard registration authority we have. The organization generates a key, makes a request, sends it to the service desk makes the checks for ICE principle, then issue the certificate, send it back to the organization, installs it, and then basically can enter the automated renewal process by renewing their leave certificates every 3 days. But for renewing this, you need a protocol adapter. PKI being fairly old, there are lots of different protocols, okay? So yet another protocol. And this protocol here is called the SCION PKI adapter on our product. So the endpoints basically renew those certificates. So what does it mean to renew a certificate? So when you have basically a system which has to be online. So first, you have to be able to validate in real time. If you take standard PKIs, very often their validation model takes always a couple of hours or days. Say we were talking about DNS validation. You may end up with 30 days waiting for someone to put a token into a DNS server so that you can look it up. And this one has really to be very fast. Then what you need to do also is to have high availability. Okay, if one of these protocol adapter goes down, then the certificate doesn't get issued, you have short lifetimes, then your whole system is basically just waiting, not being able to communicate, not able to do the validation, receiving the new certificate. So basically this means that you need to have, at least at the entry point load balancers, you need to have active endpoints, okay? And as soon as you start with this, you basically go down all the chain to the back end on the CA, which also has to be active, which means the DB has to be an active cluster, which means your HSMs have to be active in the cluster. If one HSM goes down, then you cannot sign. So it's not such an easy implementation on a larger scale. And worst of all, what happens if the system doesn't, reply or respond at all? So you basically have to build in some failover mechanism which sends you to another CA, okay, who can take then the lead, issue the certificate, and then at some point come back to you. So what does it mean? Are you going to trust this or the CA? What are the processes you need to put in place? Is the CA actually just going to issue a certificate, or is it also going to onboard a new organization? And then when it comes back, because you sign your request with your previous key, you have to be able then to validate back up to this third-party CA. So there are quite a number of operational issues. So in the standard, we have the short-lived certificate. So we have, for the root, we have 1 year. Control plane, we have the 7 days. It's basically an issuing CA, and then the standard 3 days. So in the PKI world, we know the leave certificates for digital signatures, they usually go for 3 minutes. But the issuing CA is usually online for 8 to 10 years. And PKI, they are not really good at automatically renewing issuing CAs. Okay? So if you just have, a shell script with OpenSSL, you can script it so easy. shebang, bin bash, OpenSSL, generate key, boom, you have your new issuing certificate. But here, basically, you would have 7 minus 3 days, so you would need to renew every 4 days your issuing CA. And if you have a big organization where your keys are basically stored on the HSMs, where you have 4 ICE principles, where you have compliance, where you have the protocol, where you need to get the people from the different organizations to show up with the smart cards, with the guy who forgets which day it is, the other one who sits on his smart card because he has it in the back pocket, goes into the car to the meeting, and then pops the chip out of the card. You really need to make sure that you have the time to renew your issuing CA. So because the keys in the SSFN projects are on HSMs, it was decided that the root would basically live for the 11 years, 26 months for the issuing CA, and we basically have then the 3 days for the regular issuance. So usually the HSMs, or for the root, if you do it correctly, those are offline machines, okay? So you need some preparation, some organization. Either it's the whole machine is offline or the partition is offline. The issuing CA is basically always online for the signing, but renewing it basically requires you to go through a protocol. And very often, if you look for the root CAs, then if you do it seriously, you have the protocol and you also have a notary public. So doing this in an automated way can probably work with software keys, but as soon as you have a larger organization, the processes takes much longer. So basically, what do we have? What are the risks? What are the 3 things basically we had to think about? So basically, make sure that the organizations get vetted, that we have basically the control of who is joining the network or the group, because we don't want any rogue organization. Then we have highly automated, basically, the renewal, so that we don't have, that we have very few, basically, human interaction. And we have looked that we basically have built an active-active failover system with a fallback CA so that we can constantly issue. So I mentioned it just at the beginning, but what's important is to know how you are going to onboard your people, what's your process, what are going to be the checks, okay? This is basically from the experience we have also building public trust PKIs with our other partners, based on the regulation, basically, which exists for many years. We could take lots of concepts and basically bring it to the SSFN project, and having those processes basically discussed and put on paper and basically lived and modified. So having this experience really helped us a lot. So if you are looking to build up a HSM secure base type of SCION CA, then you can just come talk with us, because we have the protocol adapters, we have the TRC signing, we have made some good experience in this SSFN project.
Thank you, Marcel, for this introduction, and I'll give you, in the next 10 minutes or so, I'll give you some food for thought before you go for the real food, and give you something to talk about in the lunch break. And in my part of the presentation, I want to give you some insight on how we actually built it. Many things Marcel introduced will then come into life, because as Marcel said, it's not an easy undertaking to actually build a proper CA for for SCION or for SSFN in particular. I never built a CA before in my life, and I never intended to, but yet we had the need to actually come up with something for the SSFN to go live eventually. And so the SSFN, you probably know from earlier talks that I've done or what you have seen on the web. The picture here illustrates more or less the schematic representation of what SSFN is. It's not just an isolated an ISD as we know it from the SCION terminology. It's really also an isolated network. So we didn't want to, being the first ones, we didn't want to go into the direction of just hooking up everybody, i.e. the banks, to a publicly open network such as the Swiss ISD. That's why we decided to build our own ISD. And with that comes the requirement of a proper PKI. And if I may say so, the PKI in SCION is a bit the Achilles heel. Why? If you lose a CA in order to refresh and renew your certificates for your website, then you might lose the website, or at least the secure communication to the website. If you lose the CA for a SCION network, you lose the network. And if you lose the network for a financial, high available infrastructure, then it's chaos, it's definitely not good. So we had to design that whole thing as reliable and resilient as ever possible. And that's also why we had to come up with concepts that make the CA high available and possible to actually operate in a high available and distributed manner. Now, I thought at first, CA is something technical, but actually it's all about process. It's not so much technicalities. Of course, you need to design it well and you need to architect it well, but the first and major key element here is identification of the parties who join that closed user group network, right? So the part that Marcel explained, identification of the party needs to be done properly, and it needs to be done certainly out of band, because there is no in-band verification process such as domain validation or anything, because the company, the organization willing to join is actually not yet on the network. So you go back to the roots, you do some identification via maybe government-issued credentials, such as Handelsregister, Auszug, or any proper document that will identify the party as being the one it claims to be. So we even went to the place where we say for certain parties we need to have them identified by a notarial act, so we really get the trust, and we live up to the trust that we want to see in SSFN. Then the second thing is, if I build a high available CA, and trust me, SIX knows what high availability is. We operate a few of the systemically critical applications for Switzerland and the Swiss financial industry. Even then, I know that I will not have 100% guarantee. So it's not available, it's not going to be available under all circumstances. If I lose, for instance, network access to, for some reasons, if I do a software upgrade and at that time a party would want to renew the certificates, then there is a certain risk of failure or unavailability. In this case, you need a second CA. And that second CA, of course, needs to live up to the same standards that you implemented at your own place. Else, the trust will fail between the equivalence of the two CAs. Ideally, you have to have separate instance, different implementation or different product, different operator, different path network-wise, so it should sit in a different AS, probably separate from your own organization. And then the challenges grow exponentially, because is that second CA then also entitled to identify joining organizations? And how do I know that it works if I need it? So how do we solve these kinds of problems? So we had to implement quite a number of challenges when building that CA for SSFN, but I think we went up to the task. So we implemented what we call a primary and a secondary CA. The secondary CA is just there to provide redundancy if the primary one fails. And the secondary CA will refuse participants the issuing of the first certificate. So the actual first issuance of a certificate will definitely not be done by the secondary, only the primary is entitled to do that. Upon first renewal, after these up to 30 days, you wouldn't believe how much it takes to actually carry a certificate from email or however you distribute it over to the router and implement it. It can take days or weeks. That's why we came up with these 30 days. Upon first renewal, it's then possible actually for the secondary CA to also reissue certificates. The secondary CA also acts as sort of independent monitoring system because under normal circumstances and if the network is configured properly, it would never really issue certificates. Once it starts to issue certificates, something's wrong. Either our CA is unreachable or then a configuration mismatch is present in the network. Of course, you also need to test in the secondary CA for availability on regular basis because if the primary one fails, you want to make sure that the secondary CA is there. Then is maybe a bit a side note from the CA topic is the handling of TRCs because TRCs even play a bigger role than the CA itself, because CA you do on a day-to-day basis, you gain some experience with it, and you get also to understand how the inner workings are, and you have customers notifying you immediately if the CA doesn't work anymore. But the TRCs are a bit different. TRCs are long-lived structures. It's containers containing all the certificates of the parties involved in a particular ISD. You have the root certificates, you have the voting certificates, you have policies in there. So you have a number of key elements that define the intent, the actual purpose and the intent of the ISD. So you need to, in order to keep them valid, you could actually do this, sign those and then provide those for a number of years even. Next time you would actually get to it to re-sign the TRC and create a new version, you'd probably be stuck because you wouldn't have access to the HSM anymore, or you would have lost the keys or the knowledge or the people or all of it. And then inadvertently, the ISD will stop working again, which is unavoidable and undesirable, of course. So each year we do then the TRC renewal. That's why we did it this way. So we structured it that we would gain continuous experience with it, but it's also a source of continuous stress, and risk for heart attacks is never as big as during the time when we prepare for the TRC. So we do the TRC validation and renewal again later this month. I hope that everything will work fine. Probably it's the last one that we'll do with the older version of OpenSSL, which still has access to the keys in the HSM. For next year, I'm not so sure. So please, I mean, TRCs, pay attention to these processes. At the beginning, it's easy to actually go through, but over time, you need to maintain this. So it's not so much about technology, but more about the process. You can talk to each one of us during the lunch break. And obviously, I'm also going to be here in the afternoon, so we can have an interaction if you're interested into more of these topics. And with that, we'll go over to questions, okay?